All right, so I think that I posted this slide for you, did I not, before? And so we're going to look at the other types of equations that we have not looked at before. And this will be posted, so if you want to go back and look at it, you can as well. All right? So what kind of equation is this? All right, so that means that I can take square roots of both sides, possibly. I can factor, possibly. I can use the quadratic formula or complete the square. All right, so the first thing that I need to do, I know, for the quadratic equation is to make it 3x squared plus 9x plus 5 equals 0. So the fact that it's got a 9x term and not just the 3x squared term prevents me from taking square roots of both sides. Are you with me? Well, I can assess whether it factors or not really quickly, because what would the AC value be? And what's the B value? All right, so when I look at it that way, I mean, I could do like 1 and 15, and I could do 3 and 5. I think that's all my options, aren't there? So here, 1 plus 15 is 16, and 3 plus 5 is 8. So do you agree with me? It doesn't look like factoring's going to work. Factoring's out. So then what I've got to do is figure out, well, do I want to do the quadratic formula, or do I want to complete the square? So what would you tend toward here, and why? All right. Why quadratic formula? Why'd you raise your hand, Kate? What are you thinking? Well, does 3 factor out of 9? So you could, do you agree? I could say, well, this is the part that I complete the square with. I need to move the negative 5 over. Are you with me? So I could say 3 times x squared plus 3x, and I could complete the square. But now that you look at it that way, really, why do we not want to complete the square? Well, you're not going to use decimals, but why is completing this? 3's not even. All right. Paige, did you have a question? That's what you were saying? Okay. So on this one, guys, I can come back to this, but you're right. I think the quadratic formula is your easier choice here. I can assess that quickly. So I'm still going to do this on the next slide. But I am going to use quadratic formula because completing the square was going to have a lot of fractions and so forth. We can go over it in just a minute. But I'm going to say x equals negative b. What is that? Plus or minus the square root of b squared. What's b squared? Minus 4a. What's a? C. All over 2a is 6. So I'm always going to ask you to set it up the same way. All right? So now your next step, I'm treating you like you're in my Algebra 2A class, is what is the one and only number that you get under the radical? So what is 81 minus, all right, 81 minus 60 is 21. So the answer is real, okay? So if it's real, I don't separate it into a plus bi form. If it's real, I'm allowed to leave it together. Does the square root of 21 break down? No, okay? So this answer is completely okay because it doesn't reduce. I could also, though, say that is negative 9/6 plus or minus the square root of 21/6, and then this answer could be reduced. So an alternate form of the answer is negative 3/2 plus or minus 21/6. But guys, remember, I'm telling you, this answer is totally fine, and this answer is totally fine. So either one of those is acceptable, okay? So if the answer is real, you don't have to do is, you're not locked into a one particular format. So if I went back on this one and I were to get, I want to get the same answer, remember that what you do is you say x plus, well, what do you do with the 3? And that's just 3 over 2, all right? Don't even think about fraction, or don't use decimals. Your eyebrows will fall out. You'll look like the Mona Lisa. Nobody will like you. So what do I do to put here? No, I just told you your eyebrows are going to fall out if you keep using decimals. 9/4, because you squared the 3 over 2. So 9/4 here. And then what do you do to figure out what balances the equation? Yeah, so you've got to say, okay, that was 3x squared. I had that already. That's 9x. I had that already. This is 27/4. That's the new or 27/4. That's what I meant to say. That's the new thing. Okay? So now, do you agree with me that -5 is -20/4 plus 27/4 is 7/4? Now, remember, why do we complete the square? Because it creates an equation where we can actually take square roots of both sides, which is the easiest way to solve quadratic equations. They're just not always set up to work like that. Do you agree that if I multiply both sides by 1/3, then my 3's over here cancel, and over on the other side I get 7/12? Are you all with me on what I did? So now I'm going to take the square root of both sides, but I'm going to go lickety-split. Do you agree that I've got to take the square root of both sides and subtract -3/2 over? So why don't we combine those into one step and subtract the -3/2 over and take the square root of 7/12? How do you take the square root of 7/12? Square root of 7, square root of 12 separately. How are you so far? You with me? So that's going to be -3/2 plus or minus the square root of 7. Do you agree that 12 can be broken down into 2 square root 3? So I need to break it down. Then I can go, oh, so I've got to rationalize by multiplying that by the square root of 3. Over the square root of 3, I'm multiplying by 1. So across the top, the square root of 7 times the square root of 3 is the square root of 21. And on the bottom, the square root of 3 times the square root of 3 is 3, times 2 is 6. Are we okay? Now, is that what we got the other way when we separated the answer? Okay. So this is doable, but this class is about making choices that give you the course of least resistance. This is the better choice on this problem, don't you think? It's faster, it's easier to manage, all that stuff. All right, now, what kind of an equation is this? One with radicals. So that means we've got to be careful about extraneous solutions. So what do you do to both sides of an equation to undo a square root? Square it. But guys, you don't want to square both sides with 2 radicals sitting on the same side of the equal sign. I want to move one of these radicals over. Which one seems like the easier one to move? I would move that too. Now, you've got to square both sides. That's not the same thing as squaring the individual terms. Okay? So we need to make sure that you know how to square both sides of an equation. Hey, let's do some extra practice. Side note for a minute. Do you know how to do 3a plus 2 quantity squared? Just like that. So that you don't have to write out 3a plus 2, 3a plus 2, and do FOIL. Do you know how to do that? Because it's an awfully helpful trick. All right, what we're trying to get rid of is this. We don't want to do this. It takes time, and there's a faster method. So first would be 9a squared, right? And then when you do outer 6a, and when you do inner 6a, right? So that means I'm getting 12a. And when you do last, you've got plus 4. Did you see what I did? So quit this business and realize, square the first, multiply the first term by the second term, and double it, because you do the outer and the inner thing. That doubles it, and then square the second. Yes? Now, do better on this one. What is 2b minus 7 squared? Roll it. No, that was good. Yeah. 2b quantity squared is 4b squared. 2b times -7 is -14b. Doubled is your -28b, yes? -7 squared is 49. Good? Now, why, like, that's random. Why'd she bring that up? Well, because that's where we are in the problem. What is the square root of x minus 20 all squared? That's the easy side. But look here, on the right side, I've got to square a binomial. Yes? Yes. I'm going to try to get them and just... Yeah, I was about to say, I'm just going to hand you the list. All right, guys. So when I square the first term, what do I get? 100. Now, when I multiply first by second, I get negative 10 square root of x. Double it, and you'll get negative 20 square root of x. And then what do I get when I square the second term? Plus x. Yeah, so this negative and that negative will always match. If that's a positive, that's a positive. But this one's always positive, because whether you square a positive or a negative, it's going to turn out positive. Okay? So now let's see where we're at. Well, we're going to need to isolate the square root part again, because we're going to square again. I'm going to say I've got negative 20 square root of x, but I'm going to move everything else to the left. So what about this x? Oh, minus that x. They cancel out, so these are gone. And then what about negative 20 minus the 100? So at this point, you're allowed to square and then divide, or you can divide and then square. So I divide first if it keeps me from getting fractions. So can I divide right now without getting fractions? What do you get? Square root of x equals what? If I were to divide and it gave me fractions, I would square first. And that way I don't bog myself down early on with fractions when it's not necessary. What do you get when you square both sides? You get 36. So let's check that and make sure it's not extraneous, which means let's make sure it goes into the original equation and actually makes things turn out right. So when I check, the square root of 36 plus the square root of 36 minus 20 equals 10. All right. I'm normally going to just do this in my head, but what is the square root of 36? Now, 36 minus 20 is, and what's the square root of 16? And that's equal to 10, and clearly that's right. So x equals 36 is a good answer. It's not extraneous. Are we all right? So your biggest issue with equations that have square roots, sometimes what might happen is that an answer will work in the squared version of the equation, but it won't work in the original version of the equation. So that's why you have to like run it all the way through to make sure it's actually working. Okay? All right, so you've seen one of those before, but those are pretty tough little boogers. People get confused. Now this is a lot easier. All right? So what do you think you've got to do to both sides of the equation? All right, you could take it to the 5th power, but I can do you one better. Take it to the 5/3 power. I'm going to bring this down so I can reach it. I used to be able to reach it with my old board, but they gave me a new board last year and they hung it higher, so now I can't reach anything. So if I take both sides to the 5/3 power, then I can take care of it just like that, and we can discuss fractional exponents. So what do you do power to a power? What do you do with your powers? So that would be x plus 2 to the 1 power, would it not? And x plus 2 to the 1 power means x plus 2. Now remind me, what does 8 to the 5/3 power mean? Cube, it means the cube root into the 5th. And you can write that as the cube root of 8 all to the 5th, or you can write it as the cube root of 8 to the 5th. The way you write it makes no difference. But guys, you can do the cube root first, or you can do the 5th power first. Well, which one can you do without a calculator? Do y'all happen to know 8 to the 5th? I didn't think so, but do you know the cube root of 8? Yeah, what is it? Yeah, so this is the same thing as saying x plus 2 equals 2 to the 5th. You should know 2 to the 5th, 32. And so then x equals 30. Are we okay? Now, the one time that you need to be careful with this process, because usually power equations like this are pretty easy, but just FYI, if I had given you something like, what about x to the 4/3 power equals 16? All right, this is one that's the same kind of thing, except there's one thing you got to be careful about. What would you do to both sides quickly? Yeah, so if I said, well, I'm going to make this 16 to the 3/4 power. So I did both sides to the 3/4 power. Are you with me? The issue here is, do you agree that you're taking the 4th root? That means you've got a plus or minus. Because if you do 4th roots or square roots or 6th roots of both sides of the equation, you got that plus or minus situation. So technically, this is plus or minus the 4th root of 16 cubed. I don't think you know 16 cubed, but I do think you know the 4th root of 16. And then what's 2 cubed? Yeah. So this would be x equals plus or minus 8. Are we okay? So when you're doing those crazy exponents, you can do the square root, cube root, 4th root, 5th root part first, or you can do the power first. We work with calculators as much as we can. We work without calculators as much as we can, so it's usually better to go small before you go large. So root part usually before exponent part is what works best. Yes? Say that again? Yes. Okay. So I noticed that when I said to the 3/4 power, that means I'm taking the 4th root. Are you with me? And so that means I've actually taken the 4th root of both sides of the equation. And anytime you take an even root of both sides of the equation, if I had slowed it down, I could have said, okay, x to the 4/3 equals 16. And I could have said, I want to do the 4th root of both sides. If I do the 4th root of both sides, I get the plus or minus situation. So that would be x to the 1/3 equals plus or minus the 4th root of 16, which is plus or minus 2. This is me slowing things down. Are you with me? Then you cube both sides. I just did it all in one exponent, but I have to be careful. Are we okay? All right, good deal, Pickles. So I know I'm hurrying because I don't see you enough, so I'm trying to make this useful. So we're going to do more absolute value equations later. But we're going to think through absolute value inequalities like we think through absolute value equations, and I might say this a little bit different than you've heard it before, because I'm trying to get you to really understand what it is you're doing, so that it starts spanning different types of scenarios. So in all absolute value equations, you attempt to isolate the chunk. That's what I call the part in the absolute value bars. So I don't have to keep saying the part in the absolute value bars. I'll just say the chunk. So if you isolate the chunk, do you agree that I subtract 14 first? Guys, you cannot multiply through the absolute value bars. You don't want to add to it, subtract from it. The absolute value bars kind of puts the 2/3 x minus 9 in little gel bars. And we're trying to free it from the gel bars so then we can actually isolate x. What is 8 minus 14? Now I'm going to divide both sides by -2. So I'm going to get chunk equals 3. Okay? I'm going to do something that you're not used to seeing done, but I want to make sure you're thinking about this right so that when you get into the rest of the inequalities tomorrow, you'll understand because you've heard this. This says 2/3 x minus 9 is 3 units from 0. That's what that is saying. All right? It doesn't just say 2/3 x minus 9 is 3. because then it would actually be written 2/3 x minus 9 equals 3. All right? If it's got the absolute value bars, you have to think 3 units from 0. Are we okay on that? All right? So that means if you look at this on the number line, where all on the number line could you place a point that's 3 units from 0? -3 and +3. So you think 3 units to the right and 3 units to the left. So I could put it right there on the number line, or I could put it right here on the number line. Are you all with me on that part? Well, remember I'm saying it then could be at -3 or +3. So it, if I'm looking at that, it is 2/3 x minus 9. And it could be on -3 on the number line, or it could be on +3 on the number line. That's why you break absolute value equations into 2 separate baby equations. All right? Now I've got 2 equations that lack absolute value bars, which means I can start moving things around to isolate x. You follow what I've done? All right, so 2/3 x equals, what is -3 plus 9? So I'm going to add 9 both times. So over here I get 12. And then on both baby equations, what am I going to multiply by? Bingo. So you said multiply by 3 over 2. So 6 times 3 is 18 over 2 is 9. And multiply by 3 over 2. So 12 times 3 is 36 over 2 is 18. Are we okay on what I just did? All right. You okay? I'm going to talk the same way about inequalities, and you're going to do more inequalities tomorrow. We're going to try to get into just some baby inequalities today.
So on the side number 3, what if it was like 3x minus 1? How would you do that?
On the side what?
So you know where it's like equals 3, but what if there was actually another x on that side? So it's like 3x minus 1.
You mean like this equation? There we go. So I'm one step ahead of you. It's a good question that you were asking. You already knew I was going to. So on this, I'm going to do the same kind of thing. All right? Think about it on this. Once I got the chunk isolated, then I said the inside portion equaled 3 and the negative of 3. So I'm going to do the same thing here. I've got the chunk isolated on this side by itself. So I can say that the inside portion equals x squared minus 10x, or the inside portion equals the negative of x squared minus 10x. So I'm kind of doing the same operation, I just don't have numbers on the right hand side. Does that make sense? So guys, these are the weird ones. Weird stuff can happen when you do this process and you've got x's sitting outside on the other side of the equal sign. So what kind of equation have both of these turned into? Just a quadratic equation. So I'm going to pull to the right on this one because I want x squared to be positive. So what is it going to be? X squared. You got it. I think that guy factors. So x squared has to be x times x. How could you break up 10 to get 11, negative 11? Minus 10 minus 1. So I've got 2 answers. I'm expecting to have 4 because I got 2 quadratic equations. Are you with me? But I don't. I'm only going to get 2 total. All right, I'll have to see why. So on this one, I've got x minus 10 equals negative x squared plus 10x. This time I'm going to pull to the left so my x squared's positive. So it's going to be x squared if I'm going left with it. Minus 9x. Good. So that's one that you got to be careful, right? I think this guy factors too. So I've got xx for x squared. So how do I multiply out and get negative 10 but add up and get negative 9? Negative 10 and positive 1. Nice. So you're going to find out I'm really going to push you with factoring trinomials this year, and you're going to walk out of here at the end of the term much better at factoring than you were when you walked in. You're probably already good, but I'm going to make you better. All right, it'll be a matter of survival, but you're going to be glad for it if you can start factoring like this so that it doesn't take so many steps and doesn't take so long. Yeah. Well, we don't even know what this would look like graphically. So hold that thought. I like that you're asking about hold that thought because that's a little bit above where we are at right now. But I said you were going to get 4 answers, but then I said you're actually going to get 2. Well, do you see that one answer is repeated? All right, so now you've got 3. But why am I saying you've only got 2? You have to make a note to yourself. When you do absolute value equations and you've still got x's over here, it can create some weird results that are extraneous. All right, so when I check, I'm going to say, well, what about when you check 10? Well, 10 minus 10 is 0, and the absolute value of 0 is 0. And then 10 squared is 100, minus 10 times 10 is 100, so 100 minus 100 is 0. So 10 seems to be fine. Are you okay there? That's one of our solutions. Now when I check 1 minus 10 is negative 9. The absolute value is positive 9. Here I get 1 minus 10 times 1. That's not working, is it? So that doesn't work, which tells me x equals 1 is extraneous. So I know 10 works. I'm not going to square it in again because we've already said it's a solution. When I check negative 1 minus 10 is negative 11. The absolute value is a positive 11. Negative 1 squared is positive 1. And negative 10 times negative 1 is plus 10. So do you see that that one is working? So these are my 2 solutions. But just make a note to yourself. These kind of beefed up absolute value problems can produce strange extraneous answers. I don't think you've done one like that before, have you? I think that should be kind of a new thing this year. All right, so I want to get into polynomials. And in this class right now, you'll only do the polynomials equations that straight up factor. And you might be going, what kind of polynomials don't straight up factor? The ones where you have to do the rational root test and synthetic or long division. Ring a bell? You're not doing those in this chapter. We will have a chapter where we get to that and we go back over it before I hold you accountable to that. Okay? So now we're just straight up factoring like you did on the summer packet. So everything's set equal to 0. It should be. It's a quadratic equation. Do you see why? X to the 4th power. So I know I'm going to have 4 total answers. So the first thing I do when I factor is check for a GCF. Always, always, always. You got to train yourself to make that first. Is there one? What is it? X squared. So I've got 2x squared minus 15x plus 18. Does it look like I did that right? So now, I've told you these are going to factor at this point. I do think that this factors. Hey, do you all see that the AC is 36? You with me on that? And the B value is negative 15. Can you think of 2 numbers that would multiply out to positive 36, but that would add up to negative 15? Negative 3, negative 12. All right, so I know that you all know how to go from here and like make it 4 terms and then group and yada, 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 yada. I'm trying to get you to go faster than that. So we're going to work on this. I don't want to work on it. Well, you're going to be happier if you do. Because you will like that you can go faster on your factoring if you haven't already tried this. So what times what must give you 2x squared? It's got to be 2x times 1x or 1x times 2x. Order doesn't matter. Now, that negative 3, negative 12 thing, tells you outside and inside products have to be -3 and -12. So it would have to be like this, that 2x times -6 gives you the -12, and then it would have to be 1 times -3. And then double check it and make sure you didn't goof up, because we all have one thing in our head sometimes, but we write something we didn't mean. So that would be 2x squared minus 12x and minus 3x is your minus 15x, and then plus 18. Are you with me? So on polynomial equations, you factor to completion. Will this binomial or that binomial factor again? So you're done factoring. So give me 4 answers. X squared as a factor tells me x equals 0 is a double root. You got it. So we're going to count it twice. Otherwise, you have to say x equals 0, x equals 0. You have to list 4 answers one way or another. 2x minus 3 is a factor, tells you x equals. Beautiful. And x minus 6 is a factor, tells you x equals. Nice. How are you? Yes. Oh, this is just me scratch work. I wouldn't show it. Like if it were me writing, I would write this and then this. So it's just me doing scratch work trying to get you all back in school mode. Because I figure your math brains are maybe not completely turned back on yet. But they will be. They will be. But it's always painful at the beginning of the school year after summer break. But y'all have got the double whammy because you've not been in school since March, right? So, and how many of you are like, I'm not saying anything because I'm really feeling a little overwhelmed right now? Probably some of you. And that's all right. You'll get back with it. I know you will. All right, so again, we have a quartic. How many solutions will you show me? 4. Okay, does this quartic have a GCF? No. But it still is a trinomial, so I still should try AC. Are you with me? So what is your A times your C? Yeah. And then what's your B? Now, can you think of 2 numbers that multiply out to positive 64 but that add up to negative 65? Negative 64 and negative 1. All right, guys, that means I'm not going to do all the grouping and all that stuff because I'm trying to push you a little bit faster. Now, we know that 4x to the 4th can be 2x squared, but it's not going to be in this case. It's going to have to be 4x squared, 1x squared. And you might say, why do you know that? Because I have to have the outside product and then the inside product worked out to be negative 64 and 1. All right, so if this is 1 or negative 1 and this is negative 64, I normally don't write all that. I'm just kind of showing you my thinking. If I had made that 2x squared, there was no way that the inside product could be a 1. Are you following what I'm thinking? So you're kind of doing trial and error, but you're kind of directing the trial and error by knowing you need negative 64 and negative 1. So you've got several clues that you can kind of figure out how to put the puzzle pieces in. So 4x squared times what would give you a negative 64? And then it would have to be negative 1 times 1 to get a negative 1. Are we okay? So I'm trying to get you to go a little bit faster with your factoring. And once you get used to this, you'll start rocking it. But you got to practice it. It could be 3 or 4 weeks before you really start feeling on top of this. Now we need to factor to completion. Is 4x squared minus 1 completely factored? What should it be? Difference of 2 squares. It's my absolute favorite kind of factoring ever. I think it's the easiest to spot and the easiest to implement. What about x squared minus 16? Is it completely factored? So what is it? Okay, so now can you hit me with 4 solutions? Plus or minus a half, plus or minus 4, absolutely. You can list them separately or you can list them with the plus or minus. It's up to you. Are we okay? One more of these, and then I'm going to try in our 5 seconds we've got left to do some inequalities. So what kind of equation is this? Cubic. Yes. So how many answers do you know you're going to get? 3. But what do you do? Because I told you we're factoring. What do you do with 4 terms? Group it. Yes. We love grouping. Do not stick parentheses in there upon penalty of death, guys. Parentheses means you're multiplying things and you're not there yet. So don't stick random parentheses in there. If you want to say I'm grouping these two and I'm grouping those two, like underline them or something. All right? What factors out of my first pair? X squared times what? Remember, you got to bring the sign that's in the center, bring it down. All right? What's the GCF for 9x and 18? And it better be times the x plus 2. If it's not times the x plus 2, then you're not grouping. It's not working. But if I check it, that would be negative 9x, which is right. And that would be negative 18, which is right. So it's grouping. It's not factored because it's got a minus sign. So you've got to factor it. So it's got to be something times something now. What would it be? And are you completely factored? No. So that's where I'm going to go, wait. That's a difference of squares. Difference of squares makes me happy. So x equals plus or minus 3 and negative 2. So polynomial equations of cubic, quartic, quintic, and higher, they do just factor in this first chapter. All right, so factoring is really what we're practicing. Are we okay? Yes.
So would you like mark off if we forgot to mention like difference of equals?
I'd dock you a point, yes. Fair question. Are we okay? All right, so let's look. Actually, I'm going to skip this because I'm going to say more about it. Let's talk about inequalities because that's on your video for tomorrow. Let me just make sure that you know a few things about graphing and interval notation. And also I'm going to mention one more thing. But are you with me that if you graphed x is greater than or equal to 2, it would be a closed circle on the number line. Would you shade left or right? All right. Do you know that we write that in interval notation as bracket 2 to infinity? So are you with me that your intervals must be read from left to right? Order matters. Brackets go with closed circles. Parentheses go with open circles. So on this one, x is less than negative 10. So I'm going to open circle negative 10, shade left. All right, guys, you all have A3, right? A3 is already posted online, so y'all can look at the assignment A3, and I will see you Wednesday. Don't forget, you can come in before school if you want. I might try to do a little video just to catch you up on what we didn't get to.